Good afternoon, Internet friends, and welcome to Dev Update number 7. This will be a short one because it's just part 2 of update number 6. I wanted to break the actual publish and verify demo into a separate video because I know most people probably don't want to sit through a tour of the code architecture. That said, I do want to draw a little diagram real quick because I think it makes it a lot clearer what's going on in the demo. Last time I explained how an individual election node works, and I showed running a series of tests that takes a pre-generated set of election artifacts, starts up a bunch of nodes as if they were independent people running that blockchain election, and uploads them all to the blockchain in the correct sequence to make the smart contract work. So now I want to reuse that same series of tests as the publish half of the publish and verify demo. As before, each node will be talking to Cardano. Both the publisher will be publishing transactions, and the subscriber will be listening for events generated by other people publishing transactions. But now I'm going to tack on a little bit of IPFS code, which you didn't see in the last part. It's pretty simple. All it is every node, before it's about to publish a transaction to the blockchain, also publishes the corresponding file to IPFS. I also mentioned last time that the subscriber has a callback functionality, so you can tell it to do something whenever it detects an event. And so what I've done now is I've written this custom subscribe script, and all it's going to do is watch the blockchain, and every time someone announces a public record, it's going to fetch that public record via IPFS. And it'll assemble all the records into a folder that's in the same format as I was using back in milestone 1 when I wrote the original verifier. And then at the end, I'll just run the original verifier on it and verify that everything still passes. I'll call this verifier verifier 2 because the test election actually already includes an official verifier 1, and I don't want to mix them up. All right, let's run the demo. First, I'll start the Docker containers. And let me just check that the Cardano node looks like it's running properly. Looks good. Same thing with the IPFS node. Also good. All right, now I go into the off-chain Nix develop environment, and we can run the publish script. And same thing for the verifier script. Go into the Nix develop environment and run it. One last detail that's important here is the verify script takes 3 parameters. One is the policy ID of the parameterized election script, and then the other 2 are the slot number and the block header hash to start scanning the blockchain from. And the reason you need those is so that you don't have to scan all the way from Genesis. You can just start from like 30 seconds before the election starts, and it's very fast to read the whole thing. In the final version, I'm planning to distribute these by QR code, but for now I discovered it's very convenient to just put a statement in the publish script that prints them to the pytest.log, and then I have the verify script grep it out of the log and reconstruct it that way. Now we just let everything run. All the nodes in the publisher script should be uploading things to the blockchain and to IPFS, and the verifier script will print out blockchain events as it sees them, and you can watch it accumulating public record files in the lower right. And in something like half an hour, it should be able to verify the whole election. This is also a good time to take a look at these transactions being posted in a block explorer. We'll start at my dev address, which you can see here, and you can see I've been doing a lot of test transactions lately. Here you can see this latest one should be the init election transaction. That's the funder creating the admin STT and sending the admin collateral. And then if we click on the admin token, we'll be able to see subsequent transactions published by the admin. And this third one is probably the most interesting. This should be add subchannels. Yeah, here we go. Okay, so you can see this is the contract address, and all the state thread tokens are locked to it the whole time. And those other 5 ADA UTXOs at the bottom are the collateral being sent from the admin to each of the other nodes so that they can interact with the contract too. And we can do the same thing with each of those state thread tokens. We can open them in a new tab and we can watch the series of transactions being published on that particular channel. And I think during an election, this is probably the thing that would be most useful, would be just people might want to look at the channels published by the ballot encryption devices. Other than that, I'm not sure how useful this would be for a general audience. It seems like it's actually weirdly more of a developer-centric thing than looking at the CLI output, which seems clearer to me. I guess maybe the lesson here is that any non-trivial dApp kind of needs its own interface. You can't rely on a block explorer. Okay, let's see if the verifier script is going to finish successfully. Ta-da! I don't know about you, but I still find it kind of magical. The verifier itself is the same code from milestone 1, so I don't think we need to go over it again. I'll just quick scroll through it so you can see what the output looks like. Okay, so that's all the important stuff. Just two little things before we're done for today. One is that I put in log statements so that you can see how much it costs to run each part of the test suite. The total cost to run this simulated election was about 30 ADA, or a little under $5 at current prices. And I think that's an extremely good deal given the economic security you get from the blockchain. It's also pretty good considering that I haven't optimized this contract at all. It's full of just hundreds and hundreds of trace statements, and I'm re-adding at each step instead of doing a reference script, and I'm sure it could be optimized a lot more. But I think for this first version, correctness is the important thing. Cool. And then the last thing is I just want to show you that you can rerun the verifier at any time later, and it will zoom through the whole election process much faster and get to the same result. Yeah, so here you can see after the election, it only takes 13 seconds to verify everything. This has been Dev Update 7. Join me next time, and I should be pretty close to having a complete demo of this thing pulled together and be working on a talk for it.